I hope you can find it interesting. So, not to waste more time, or not to waste your time, let us get into it. I'm sorry for the sound in the background. Recording this video at home, so you may hear some sounds in the background. You may hear something like an inverter on, maybe it's from my other computer over there, but I will try to keep the noise to the best way that we can have some problem there. So thank you very much. So let us get into it. First, let us look at the definition of the word linear algebra. What does that word really means? Well, actually the word linear algebra just mean the branch of mathematics that study linear equations or linear systems of equations, and then how we can also transform those systems of equations into matrices, and then also into vectors, and then solve those systems to get a solution that will satisfy the given system simultaneously. We look at those words simultaneously, solution, as we go on. But looking at the picture down here, this is what we have here. What we have here is a system of linear equations. Is a system of linear equations. So here you can see these linear equations. There are 3 of them, and then they have 3 variables: x, y, z. We call those variables, or you may hear someone calling them unknown. Yes, they are unknown right now. So as we go on in this course, we'll be finding the values that can replace those particular x, y, z that will make them or a solution for the system. That means those values that we can substitute in, like for the first equation, which value of x, y, and z we can substitute into this equation that will give us this side 20 equals to 20, and then when we substitute the same value in here for x, and then the y value and the z value, it will give us 4 equals to 4. And then if we come to the third equation, we substitute that particular value in here for the x value, the y value, and the z value. It gives us 8. Those values, those 3 values, if we get them, those value will be the solution for this particular given system of linear equation. When we talk of a linear equation, we are talking of a single equations that have variables, and all the variables have a power of 1, not more than 1 or less than 1. So as you can see, all the unknown or the variables in this system of equations are all having the power of 1. So that made them linear equations. To be a system of linear equation, you have to have 2 or more equations that are linear coming together. So a solution to this system of linear equations should be able to satisfy all the 3 equations simultaneously. So in linear algebra, we find a way that we can as well convert these equations to matrices like this one, and also a vector. And as we go on, we see how we can transform this system to such matrix and then vector, and then how we can solve them to also get the solution of this particular equation. Thank you. So we go to the next slide. Now, let us look at the uses of linear algebra in computer science. Sorry, I'm really focusing here on computer science because my class I will be teaching next will be linear algebra for students that are going to be studying or computer science, that is, they will be studying programming and other things. So I was like trying to give them the motivation of why they should learn linear algebra as people aspiring to learn programming. So just looking at few of the applications of linear algebra. Actually, linear algebra is not only applicable to computer science, like you can see in the first statement above here. It provides concepts that are useful in modeling many physical situations in many areas of science, including computer science. So there are other areas of science that you also use system of linear equations in. Like even you go to economics, you can use system of linear equation to model phenomenons, like maybe an economy. You want to see how two or more variables interact together, you can normally form a system of linear equation. Sometimes let us say you want to optimize a budget. So those are other areas, but for here I'm going to focus on linear algebra uses in computer science. So in computer science we have what we call a graph theory. Graph theory deal with how points are connected with linear lines or straight lines. It is also applicable in areas like social networking. Like you can see in this picture across here, this is a friend that have other friends connected here. So this particular graph here show how this person in the center is connected to other friends, and also how those friends are connected to other friends in the network or the social network. So linear algebra is used there in social networking to form the connection of friends, to model it. It is also used in graph algorithms or data structure, which we study in software engineering. In networking, when a person is interested in showing how nodes are connected on a network, they normally draw graphs. So graph theory is one of the areas where we use linear algebra, because the connection between each of the points or the nodes, like in the networking area, or friends, like in the social network area, or the graph algorithm or data structure, all the connections are all linear or straight lines. Another use of linear algebra is in linear optimization. In linear optimization, we look at registers allocations or allocations of large numbers of program variables to a small number of a CPU register. So in there we look at linear optimization, which is based on linear algebra to do such allocations. Moving on, when we look at areas of machine learning, which is one of the most hot areas today in data analysis. In machine learning, people try to build on linear regressions predictive models. So to build a linear regression predictive model, like you can see across here, this is a model, and then you can see a line between it. This line here, we call it a line of best fit. This line try to predict a point that will be what connected with the other points given in here. So normally you are given a data point, or you are given data points. You want to get a line of best fit that you can use to predict any other data point that may occur in that particular phenomenon. So this particular line is modeled with this particular linear equation. So you can see we are using linear algebra there. Also, the data set representation in machine learning is normally represented as table, wherein you have rows and columns. Each observation is represented as a row, and then about the observation you have attribute. Assuming you want to collect information on a student or student in a school, each student is an observation, and on a student you may observe the student name, first name, last name, the student age, maybe the student class. Those are attributes of a student, or we call them variables. So they are normally represented as columns. So normally they will build up a matrix that is going to be representing the information on all the students in maybe the class, in the school, and so on. So there you see linear algebra is coming into play. Relational database systems are really modeled after matrices. So you see right there they are using what? Linear equations or linear algebra. So now we go to introduction to linear system of linear equation, or linear system of linear equations. So like we stated previously, many natural occurring processes are modeled using more than one equation with many variables. So if you have more than one equation in your system that are modeling a particular situation, then you have a system of linear equation. So a solution to a system consists of values of unknowns that simultaneously satisfy each equation. Like for the given system above, x is equals to 2 and y is equals to 2 is a solution for that particular system, because substituting 2 in here will give us 2 times 2, which will be 4, minus we substitute 2, which will give us 4 minus 2, which will give us 2 is equals to 2. So that is a solution. And then that same solution, when we substitute it in here, that is 2 plus 2 times 2, which will give us 2 plus 4, which will give us 6 is equals to 6. Since these same two values satisfy this equation 1 and equation 2, we say these two values are a solution to this particular given system of linear equations. Now, a system of linear equation may have solution, one or more solutions. If the system have one or more solutions, we call it a consistent system. Contrary to that is a system that have no solution. Such a system, we call it what? Inconsistent system, because it has no solution. The one that have one or more solutions is known as a consistent system. So now, system of linear equations, like previously stated, a system of linear equation is nothing more than a collection of two or more linear equations. So here, this one here, this is a system of linear equation that have two linear equations with two variables, x and y, or we also call them two unknowns. This is so we call this a 2 by 2 system. Here we have another system of linear equation that have 3 variables with 3 equations. The variables here are x1, x2, x3. In this other one, we have another what? System of linear equations with 2 variables, x1, x2, and 3 systems of equation. Here is another system of linear equations with this one have 5 variables, x1 to x5, with 3 linear equations. So a system of linear equation have more than one linear equation. If you have just a single linear equation, then you just have a linear equation but not system of linear equations. So a system of linear equation have more than one equation into it, which are all linear. So the general form of a linear equation in n variables, as you can see, x1, x2, all the way to xn, is written in this general form: a1 to x, a1 x1, a2 x2, all the way to an xn is equals to b. Here the a1, a2, and an are known as coefficients of the variables. They are normally constant value, non-zero constant values. They could be 1, 2, 3, 4, 5. They are all real numbers. Then we have this particular b, which we may in some equation you will see it across here, so it could be minus b across here, which is equal to 0. This value, we call it the constant term. So this particular equation here is a linear equation. So here we're calling it linear equation because it is only one equation. This x1 the x1, x2, all the way to xn are known as the variables or the unknown of the system of the equation, of the linear equation. Now we come to a system of m linear equation in n variable is a collection of equations of this form. So here we can see we have more than one linear equation. We have this 1, equation 2, equation 3, and equation all the way to equation what? M. So let us call it equation M. So here we are using 2 subscript to identify the A's. The first value here stands for the roll number of the equation. So since this equation is the first equation, so we have A1, and then the first variable is this one. So we have the A11. This one is the second equation in this system, so we have A2, and then the first variable 1. A2, 2, the A2 first one is the second equation and then here we are talking of the second component of the equation, that is the second variable. You come to the third one, we have the third equation with the first variable. So on there we have the third equation with second variable. Here we have the third equation and the end variable, assuming we may have like 10 variables in this equation. So this group of linear equations coming together form a system of linear equations. So we are going to look at the case of a 2 by 2 system equation or system of linear equation. This is an interesting system of linear equations, so we look at it in particular. There are certain properties this system exhibits. So here, two equations with two variables have the following unique properties. So since we have in two equations, we have in two equations with two variables, we have a 2 by 2 system of linear equations. So that means we have in two equations, two variables. So if you have such an equation, it will exhibit one of these three properties. The two equations in this system will have different slopes and hence will intercept at a unique point. So such a system with two equations that have two different slopes will intercept, and then such a system will have a single solution. So example is this particular system in here. This particular system in here, it has two equations, right? And those two equations having two different slopes. How can we find the slope of this particular equations? To find the slope, if you have learned maybe things like algebra in high school, from the first equation we know that 2y is equals to 6 minus x, right? If we divide everything by 2, we get y will be equals to 6 divided by 2, 3 minus 1 all over x all over 2. So here, what is the slope of this particular line? We can find the slope once we have this particular equation in this form. Here, the 3 is the y-intercept. So you can see the equation here, intercept at this point. 3, you can see 1, 2, 3. And the slope is minus 1 all over 2. That is half. Or we can just rewrite this equation as y is equals to 3 minus 1 all over 2x. So minus 1 all over 2 is the slope of this first line here. So you can see the slope of the line is negative. That is, it is falling from the left going to the right. So that is for the first equation, and you can see the slope of it is half. So let us say m for line 1, which we can use as the slope, is equals to minus 1 all over 2. For the second equation, we have y is equals to 2x minus 2. What I did, I take the y across, making it positive, and then this remain where it is, and then I bring this guy across, making it negative. So from here we can see that what here the y-intercept is minus 2. So you can see the equation intercept us at minus 2. This is minus 1, minus 2, and the slope is what? Positive 2. So you can see this equation m, that is the slope of it, is positive, which is 2. So from here you can see the line is what? Rising. As you can see, it is rising from the left to the right. So since this slope of line 2 is not the same as the, or is not equals to the slope of line 1, the two slopes are different, and so these two equations, system of linear equation, have a unique solution at this point where the two lines intersect, and that particular point is 2, 2. That was the same equation mentioned before in our previous example. That was the two system of equations. Now we go to the next part, or the next situation we can have with system of linear equation that have two equations with two variables. There are times when you have two lines that are identical. That is, one is a multiple of the other line. With such equations, what happens? Their slopes will be the same. The slope of those lines will be equal, and hence the two lines will be line over each other. And such equations will have infinitely many solutions. So that is the situation with the second part here. Here we can see this first line. If we make y the subject, so we have x, we have we have 1 minus x. So the slope here m is equals to minus 1. For the second line, which is a multiple of the first equation, meaning if we multiply this particular equation by 2, you will see that we will produce the second equation. Or if we multiply this equation by 1 all over 2, we produce the first. So the both of them is, the both of them are just a constant multiple of the other equation. So that makes them identical. With that, the two equations have the same slope. Here, to see how the slopes are equal, let us see we solved for the slope of this equation. Here we have 2y is equals to 2 minus 2x. If we divide all through by 2, here we are going to have y is equals to 1 minus x. So we can see that the slope for this line 2 is also equals to minus 1. Since the two line slopes are equal, they have infinitely many solutions. So whenever you have two linear equations forming a system of linear equations and their slopes are the same, such equations have infinitely many solutions. So what we mean, this equation at this point could be a solution for the both. That is, the solution here is x is equals to 0 and y is equals to 1. The solution. Let us see how true is that. Substitute here 0 and 1. You will see that 1 is equals to 1. That makes it the solution. Substitute here 0 and 1 for y. 0 for x, 1 for y. So if we substitute that, this will go to 0. This will go to 2 times 1, which is 2 is equals to 2. So you see that this point satisfy the both equations simultaneously. Let us take another point that is already clear here. We can see it. At this point, x is equals to 1 and then y is equals to 0. If we substitute 1 in this equation, we get 1 and then 0 for y. We get 1 plus 0, which is equals to 1 is equals to 1 is a solution for this. And then do the same thing over here. Substitute 1 here for 2 for x and then 0 for y. We get 2 plus 0, which is equals to 2 is equals to 2. So that is another solution for this equation. We could take another point like here, and I don't know what it will be here. I think this, and substitute. That could be another solution for this. So any point on this two line will be a solution to the two systems. So they have infinitely many solutions. Now let us go to the third and the final situation you can have with linear equations. Here the two lines will be parallel, and you know from our high school mathematics or pre-calculus or mathematics, we know that two parallel lines doesn't meet or they does not intercept at any point. And since they does not intercept at any point, their slopes are never equal. And also there is no point that lie on the both lines. So such equations have no solution in common. So normally we can just say a solution of a system of linear equation is a point where the two lines or the equations of the lines of the equations intersect. So those are the three situations. Situation 1, the lines have different slopes and they intercept at a unique point. For the parallel lines, they run in two different directions. In two different directions. They both of them run without intercepting, and so they have no point in common, so they have no solution. Even though for the point of their slope, let me just say their slopes, like if we say for the first equation 1, y is equals to 1 plus x, and for the second one, that is, this is for this one. If we come to this, we get our y is equals to 1 plus x. Yes, they have the same slopes, their slopes are equal, but then they doesn't meet at all. They doesn't meet at all. They are parallel with the same slope but parallel. The equations are not constant multiple of each other, as opposed the place or the situation, this second situation wherein their slopes are the same, but then the two equations are constant multiple of each other. So that is about two equations with two variables forming a system of equations. So now we look at how can we solve or find a solution to the system of linear equations. There are two ways basically. So we look at one of the first way we can find a solution to it. The first way we look at is by substitution. By substitution. Substitution is normally convenient when we have system with that is small, that is system with few variables, like a 2x2 system or 3 variable system. In such a case, you can do substitution and then easily find a solution. For here, we are going to be solving this first system of equations. 2x minus y is equals to 2, that is equation 1, and x plus 2y equals 6 is equals to equation 2, which is equation 2. Here, to solve this system, let us start to do the substitution. Let us start by making y the subject of equation 1 here. So what we do, we say we take y across, making it what? Positive y. This 2 remain where it is, and then 2x, then we take this 2 from here and bring it over here, so that will make it minus 2x. So that is where we get this y is equals to 2x minus 2. We call that equation 3 because we want to reference it later. Now, if we substitute the value of y in the second equation, equation 2, we have this. That is, x remain there, so we have x plus 2 times the value of y, that is 2x minus 2, is equals to 6, which is this. So now we have a single variable in here, so we can solve for it. Doing that, we have x plus, if we multiply 2 by 2x, we have in 4x. 2 times minus 2, we have in minus 4, or equals to 6. We combine the x, that is the like terms, we get 5x is equals to 6, and we take this guy across, making it positive. So we have here 5x minus, equals 6 plus 4. So we have 5x is equals to 10. To get the value of x, what we do, we divide both sides by 5. So our x is equals to 2. So that is the value of x. Now, to get the value of y, since we have the value of x, we just go back to equation 3, since y is already defined there, and substitute the value of x into it. So here we have y is equals to 2 times the value of x minus 2, which now give us 4 minus 2. So y is equals to 2 is the value for y. You could do it this way, by taking the value of x and substituting it in any of these equations. So assuming I want to use equation 2 to solve for the value of y, I could take this 2 and substitute it here. So this will give me 2 plus 2y is equals to 6. So I will get 2y is equals to 6 minus 2. So that means 2y is equals to 4. Now if I divide both sides by 2, I will get y is equals to 4 divided by 2. So my y will still be equals to 2, which is the same as this here. So you can see that any way you could do your substitution and still get your answer. So for today, okay, let us take a look at a system of 3 by 3 linear equations to solve it by substitution, and then after this we look at our exercises and we'll stop here for today to continue on our class by tomorrow. Here we have 3 linear equations with 3 variables. So we have a 3 by 3 system of linear equations. To start off with from equation 1, make S the subject. You could decide to make Y the subject or Z the subject. The choice is yours. Any of it is okay. You still arrive at the same solution. So for me, I just decided, let me make S, since it is the first variable in equation 1 here. I just want to make it the subject here. So I want to make this guy the subject of this particular equation, or I want to have it on one side and every other person on one side, or every other variable and constant on one side. So doing that, I will have x. If x is equals to 4, if I take this guy across, it become minus x and then minus z, and then I take this across, it become minus y. So that is where I get this guy from. So I call it equation 4 because I want to reference it later on. You could leave it without calling it equation 0 or equation nothing. Just leave it. The choice is yours. Just know when you are referencing, maybe for your instructor to know, give it the equation number. So when you are referencing, you will say substituting equation 4, substituting equation 3. That would be more easier for your instructor to know what you mean. Like more especially when you are solving for a test. So here, after making this the subject, what I do, I will now substitute the value of x in this equation 2. So doing that, for the value of x, I'm going to put in these particular values. So there where I get this 4, since x is multiplied by minus, so I have the minus out here, then I have my 4 minus z minus y in the bracket multiplying the minus 1. So the y remain as minus y, and then this the z remain as z, it is equals to minus 2. So if you simplify it, minus times 4 will give you minus 4, minus times minus z will give you plus z, minus times minus y will give you plus y, minus y, z equals to minus 2. So here we can see that this x, this y cancel out this y, and then we have minus 4 remaining, and then we combine the z and z since they are like time, so we have in 2z is equals to minus 2. So with 2z equals to minus 2, we take this 4 across so that all the constant can be together. So we having 2z is equals to minus 2 plus 4. Since the 4 go across, it changes sign. So combining these two guys together will give us 2. So 2z is equals to 2. When we divide both sides by 2, we get z is equals to 1. So that is the constant value for z. Now, how can we find the other values? We know the value for z. So we want to now know the value for y and then the value for x that are a solution. So then what we do, we substitute for z in the equation 4 here. So doing that will give us, I'll replace this guy here by 1 that I found. So that will give me x is equals to 3 minus y. So that becomes the new definition of x, right? And I call it equation 5. Now I will substitute for z and x in equation 3 here. Remember my two first procedures, I use equation 1 and equation 2. Equation 3 is left out for me to use it. Now I'm going to use it. So in equation 3, I'm going to substitute this value of x, and then I will also substitute the value of z. Doing that, I will get 2 times, since it is 2x, it will give me 2 times 3 minus y, which are the values of x, minus y still remain plus 2 times z. 2 times z. So I come on further here to simplify. I have this 2 times 3 minus y minus y plus, I substitute in the value of z is equals to 2. So by simplifying further, I will get 2 times 3, 6. 2 times minus y give me minus 2y. And then the minus y, and then 2 times 1 is plus 2 equals to 2. Here when I combine this guy and this, that is the constant I have in 8. 6 plus 2 is 8. This 6 and this 2 will give me what? 8. This 8. Then when I combine these two guys, I have minus 3y, or equals to 2. So minus 3y is equals to this 2, and I take the 8 across, and I get 2 minus 8. So minus 3y is equals to minus 6. When I divide both sides by minus 3, I get my value of y. Since I now know the value of y and value of x, it is left with me now to only to find the value of x. To do that, I will simply just use equation 5. So I will substitute for y in equation 5, and equation 5 is what? X is equals to 3 minus y. And then if I substitute in there, x is equals to 3 minus the value of y is 2, so minus 2. So my x is equals to 1. So finally I have all my values. So that means these 3 values here, these 3 values, this, and this, are the solution to this system of linear equations. So I write it here as a solution: x, y, z equals to 1 to 1. So you can see x in this position, the value of a is in this position, y is in the middle, the value of a is here, and then the z here, and then the value of it is here. How can you really prove that these particular values are truly solution for this equation? To do that, take those values and substitute them in each of those equations and solve to see whether the left hand of the equation will be equals to the right hand of the equation. So since x value for equation 1 from this equation, since x value is equals to 1, we substitute 1 plus the y value is equals to 2, we say 2 and then the z value is equals to 1, we say 1. All should be equals to 4 that we have across here. This 4. So when we combine this, 1 plus 2, 3 plus 1 is 4. So we say 4 is equals to 4. So since the left hand of the equation is equals to the right hand, the three values satisfy the first equation. So they are a solution for the first equation. We go for the second equation here. Again, substitute the value into it. Here we have minus 1 minus 2 plus 1 or equals to minus 2. Here this 1, we cancel this 1, and then we get minus 2 is equals to minus 2. Again here, the left hand of the equation is equals to the right hand. These three values satisfy the second equation. We further go on to equation 3. Here now, and say 2 times the value of x is 1 minus the value of y is 2 or plus 2 times the value of z, which is 1, or equals to 2. So multiplying this will give us 2 minus 2 plus 2 equals to 2. So that means this, cancel this, and then we are left with 2 is equals to 2. Since this equation also the left is equals to the right, that simply means that these values again satisfy this equation. And since the three values satisfy the three equations simultaneously as solution, then the three values stand the proof of being a solution for this particular system of linear equations given here. So that is the proof for it. So thank you very much. You can go on and try these exercises. Try solving them using system or substitution method. Try solving each of them using substitution method. If you have any problem, you can go on my Facebook and ask a question. I will be very happy to answer you. If you have any problem here that is challenging, just let me know and we can work it out together and derive the solution. So those are the values there. You can see those are the exercises for you to try at home. Try them. For here you are going to solve in terms of a, that means your answer will have a as a constant, so a will be in your answer. The same thing over here for a, b, and c. So try using substitution method on these particular equations. For this course, you can, for my reference for this course, I will show you this book. You can get this book, Introduction to Linear Algebra, with application from Amazon or from any online store that sells book. It was written by this guy. He's a very good writer and it is a very nice book. I really admire it for linear algebra. And then you will also, I hope and I believe that you will also like this particular book. So you can get it and read ahead, read on. And thank you very much for today. I hope to see you in the next class. Please visit my YouTube channel. Find me there, Tamafaya, and then subscribe to my channel to help me grow this channel and also to show me that people are appreciating my little contribution to humanity, to education, to humanity. Thank you very much. See you next time.